So for this example, we're going to graph 3 periods of the following functions. And we need to make sure that we include the asymptotes and that we include the x-intercepts as well. Let's start off with our first function, which is y is equal to tangent of x over 4. Now remember, for the tangent function, the first thing that we want to do is we want to find what the asymptotes are. And we can figure out what the asymptotes are by using the argument and setting it equal to negative pi over 2. So we're going to start off with, let's let x over 4 equal negative pi over 2. And then we're going to use the argument again, and we're going to set it equal to positive pi over 2. So what this tells us, remember that we have asymptotes at negative pi over 2 and pi over 2. Those are the two middle ones at the tangent function. This will tell us where they get transformed to. So let's see, I'm going to multiply both sides of the equation by 4 to clear out the denominator. And this gives me a negative 4 pi over 2, which is the same thing as saying negative 2 pi. So that tells me that I have one of my asymptotes at negative 2 pi. And for the second one, we have 4 pi over 2. And that's the same thing as saying positive 2 pi. All right, so we can kind of begin the process now in regards to what this function is going to look like. Let's start off, let's draw the Cartesian plane. Let's draw the xy plane over here, the Cartesian plane over here. I don't like that one. Let's try that again. Sorry. Okay, let's start that more over here. And there we go, more over here, a little bit down, a little bit further over here. Okay, so let's start off with, let's sketching, first of all, that's okay, you can leave it on. Let's start off with sketching, first of all, with the asymptotes are going to look like. Now, normally we have an asymptote of negative pi over 2 and positive pi over 2, but when we solve the equation, our asymptotes now get transformed onto negative 2 pi. So we'll call that negative 2 pi, and positive 2 pi. And this is 0, it's halfway down the middle. So what this means is we have a new period. First of all, I hope you can see that we have a new period of 4 pi. The distance from negative 2 pi to positive 2 pi is going to be 4 pi. 2 pi units over here plus 2 pi more units over here gives us 4 pi. So that means every 4 pi we're going to have a period. So if we want to figure out what the other asymptotes look like, well, 2 pi plus 4 pi, so let's do 1, 2, 3, 4, is going to give us 6 pi. We have 6 pi over here. And then negative 2 pi, now we're going to subtract 4 pi. And then we have another vertical asymptote over here at negative 6 pi. Okay, so here we have 3 full periods. Now, we also need to find what our x-intercept is, and the x-intercept is going to be exactly halfway between each one of these two periods here. So what that means, halfway between negative 2 pi and 2 pi is 0. So we're going to have an x-intercept here at 0. Halfway between 2 pi and 6 pi is going to be 4 pi. So we have an x-intercept over here at 4 pi. Halfway between negative 2 and negative 6 is going to be negative 4 pi. So we have an x-intercept here at negative 4 pi. And then we're just going to draw the function. Remember, the function looks just like x cubed. Okay, and so this is 3 periods of this function y is equal to tangent x over 4. Let's do the same thing for b. I'm just going to bring that down here. So now let's graph the function y is equal to negative 4 tangent 3x. Okay, so let's talk about how to graph this function. And again, the first thing that I am going to do is I'm going to look for the two consecutive vertical asymptotes. And again, we do that by setting the argument. Let's do this one in blue. We do that by setting the argument equal to the two original vertical asymptotes, which is negative pi over 2 and then positive pi over 2. So we're going to do 3x is equal to negative pi over 2, and then we're going to do 3x is equal to positive pi over 2. So we'll divide each one of these by 3, or we can multiply each one instead of dividing by 3. Let's multiply each by 1/3. I think it's a little easier to see in that case. So let's multiply this by 1/3 as well to clear out that 3 that's stuck to the x. And so what this tells us is negative pi over 6 and positive pi over 6, that I have two asymptotes. I have my vertical asymptote at negative pi over 6, and I have a vertical asymptote at positive pi over 6. So this will give us the information to get started with this function. Let's begin with, again, let's graph Okay, this is what we know so far. We know that we have a vertical asymptote over here at negative pi over 6. We know that we have another vertical asymptote here at pi over 6. So let's draw these. So what this means is that our period changed. Let's talk about what the length of our period is. Now again, remember the length of our period is one complete cycle, which means the distance from the two consecutive vertical asymptotes. So here's our first one at negative pi over 6. Here's another one at pi over 6. The distance between these two, if we're going to travel from negative pi over 6 to 0, that's pi over 6. And then from 0 to pi over 6, that's another pi over 6. This means we have 2 pi over 6, which is the same thing as saying pi over 3. So we have a period now at pi over 3. Okay, that's the first thing you should be comfortable with. So what that means, let's do this next endpoint over here. Well, if we're starting at pi over 6, and if we have a period at pi over 3, that means to find out what this next vertical asymptote is, we're going to add pi over 6 to pi over 3. So we take pi over 6 and add that to pi over 3. That is the same thing as saying pi over 6 plus 2 pi over 3. This is plus 2 pi over 6. 3 times 2 is 6, and then 2 times pi is 2 pi. So that gives us 3 pi over 6, which reduces down to pi over 2. So this over here is pi over 2. Similarly, to find the other asymptote over here, to find out what this asymptote is here, now we're going to take negative pi over 6, and then we're going to subtract one full period from it. That will tell us what our next vertical asymptote is. So negative pi over 6 minus pi over 3. And you'll see it's a kind of similar process here. That is going to give us negative pi over 6 minus 2 pi, negative 3 pi over 6, which is equal to negative pi over 2. Okay, so far we have the periods in regards to vertical asymptotes. We have a period here, we have a period here, and down the middle, and then we have one over here at the right. So now we have to find our x-intercepts. And remember that the x-intercepts occur exactly halfway between. In this case, the half is kind of easily found because it's at 0. So we have an x-intercept here at 0. Now the x-intercepts here are a little more difficult. We have to find out what point is exactly halfway between pi over 6 and pi over 2. To find the midpoint, or to find that point that's right here halfway between them, it's like finding an average. So you add them together and divide it by 2. Pi over 6 plus pi over 2. That's the same thing as saying, let's see, 2 times 3, 3. 4 pi over 6. Which gives us 2 pi over 3. Divide that by 2. That's the same thing as saying 2 pi over 3 times 1/2. Oh, sorry about my terrible work over here. 2 pi over 3 times 1/2 is 2 pi over 6, which is pi over 3. So the distance halfway between pi over 6 and pi over 2 is pi over 3. And similarly, it's symmetric because there is no phase shift, so this one's going to be negative pi over 3. But you can do the same thing. You can add these two together and divide by 2. Now, we know what the normal tangent function looks like, but notice we multiplied the outside of a function by negative 4. The 4, which is the amplitude, plays no effect into the tangent function. Remember that tangent functions, we don't define the amplitude because they already travel from negative infinity to infinity. But the part that is important is the negative part. Remember, the negative part means that we're going to have a reflection over the x-axis. So normally our tangent functions look like this, like x cubed. Now when we multiply it by negative, now they're going to look like negative x cubed. They're going to look something like this. And that's it. Here are 3 complete periods of this function y is equal to negative 4 tangent 3x.